Well, I'm so happy to be here again. You're such a wonderful audience always, and I feel very humbled that you would want me to come back and speak again. And I spoke several years ago on ancient civilizations and the cycle of the ages, and then came back a couple of years ago to speak on nanotechnology. And so tonight, I'm going to do something kind of unusual because I'm going to, in some ways, combine this a little bit. I think we focused too much on technology, and we're going to really get into technology, but we're also going to balance that a little bit with the spirituality that is needed in our time. So I haven't done this before, so this is going to be somewhat new. And the first part's, introducing the subject, that, I'm using some of the things that I usually talk about, but then we'll go off into new frontiers. And now, I know I've worked on the bleeding edge of technology, but what about all of you? Do you ever feel like you're living on the edge? Maybe not quite like that, What about the aesthetic edge? Well, no, not really, but yes, the inside edge, right? That's where we want to be. Okay. So now, giving you a little overview, I'm going to talk a little bit about some of the new types of technology that we're doing in the world. And sometimes you think, oh, gee, we're going to talk about manufacturing, time to go to sleep. But no, the things that are being done are quite exciting. So there's a lot of possibilities with additive layer manufacturing that I'll get into, and then how that transitions into nano manufacturing, nanotechnology. And then we go into the future of technology. What is that going to be like? And then we're going to ask some real questions of what kind of things are being focused on and what might be wrong, and how can we correct that? And then kind of look at ancient civilizations that gave us all kinds of blueprints on where we are really going. And so about halfway through, it should be about midnight. We should finish around 2 or 3 a.m. Are you ready? Well, I do actually plan to do this in 1 hour. So, Now, the technology part kind of came to me back in 2003 when I was chairman of the National Rapid Technologies and Additive Manufacturing Community, and composed of thousands of members. And at that time, I started these tech groups, national tech groups. And the one that I always had dreamt of was the nano manufacturing tech group, because the government is spending billions in research in nanotechnology, and so are other countries. And I felt that because the Society of Manufacturing Engineers, focusing on manufacturing, really should do something and have a vocal presence in nanotechnology. But most of the people are focusing on nanotechnology, not on the nanomanufacturing aspect of it. And so I started that group, and even in the last couple of months, one of our webinars, we actually had attendees from 5 different countries, one person from Lithuania, and I thought, wow, we've really come a long way with this group. So it gives you a little background. Now, starting out first with additive manufacturing, most of you don't know much about that unless you heard my other talk a couple of years ago. And it's known as additive manufacturing, additive layer manufacturing, rapid prototyping, rapid manufacturing, direct digital manufacturing, solid freeform fabrication, or 3D printing. Have any of you heard of 3D printing? If you raise your hand. Okay, a few of you. Yeah, you see it in the news periodically. All that's based on additive manufacturing. And what's so interesting about it is that first, we have to differentiate it from regular machining. Like if you have a lathe or a milling machine, you have a cutter, and the cutter is cutting apart. And it's like a sculptor, you're chiseling away till you get what you want. Well, in a machine shop, you have the cutter moving in like X, Y, and Z, and turning and cutting the metal part or plastic part, whatever it may be. And now if you have a very complex shape, then you have what's called 5-axis NC machining, where the cutter doesn't just go X, Y, and Z, but it also swerves in the I vector and J vector directions. So it can move all the swerving, and it's very complex type of motion. And I used to do that type of programming back in the early 80s. And then people came up with this idea of additive layer, where instead of cutting away from something, you start out with nothing and you do it layer by layer. And that way, all that complexity of 3 dimensions and even 5 axes is gone. It's reduced down to layers of X, Y. That's all. And you just pile up the layers, and they melt into the previous layer or merge into the previous layer, and you get these kind of parts that you can make, you grow on the machine. It sounds funny, but you grow it. You grow it out of nylon powder or other metal powders. And what happens is that you're actually cutting, you're like using a laser, for instance, to melt layer by layer. And so as you make this part's already like this in CAD, in the computer, when you design it. And it's all these little gears are equidistant from the center portion that it turns on. Because if it were touching, then the laser would fuse it together and this thing would not turn. But so you design it like this, and then when it comes out of the machine, it's fully functional. There's no assembly required. This is completely working as is. We can grow an entire, like a grandfather clock in the machine, in these type of machines, and when it comes out of the machine, all you do is add the weights and start the clock up. No assembly. No. So this is the type of thing that's possible with additive layer. And that's what's so exciting, that when you now go down to the nano level, you can understand at the nano level, when you're a few atoms in size, building with individual molecules, you can't have a little cutter in there trying to cut stuff, because what are you going to cut? You can't cut an atom, So what you're doing is you're building up layer by layer. So this additive technique is used at the nano level as well. And most people in nanotechnology aren't even aware that this additive layer type of process is being used and what the power of it is. And so this has been kind of the thing that I've developed over the years, and so it's a completely unique approach you won't find in any books. So let me pass this around. You can look at that. This is made out of nylon, grown out of nylon powder with a CO2 laser. And I think I'm getting a little ahead of myself. This is, I love this slide. I've used it for years now because I haven't seen anything that tops this, And the reality is, in this type of additive layer manufacturing, you model the ship inside the bottle in the computer. And then when you grow it layer by layer, you can see that if you're halfway through, the bottle's already closed off and part of the ship inside has been built, and you're looking at it halfway, and you can see how there's the sail there, and there's the ship in here, and here's around it is the outline of the bottle, and then it keeps growing, and then it starts to close off, because this thing keeps going down inside the chamber where that part's already been built, and then you keep adding till it kind of closes off with the top of the bottle, and you're done. you take it out of the machine, and of course the ship's already in the bottle, you see. So that's what's so unique and powerful about this. So here's a little bit of an example of it. You can see there that, you can imagine if this were the ship, that you're halfway growing that portion, and there would be part of the ship inside there that's being scanned layer by layer. And after each layer, this roller rolls new powder across from that side, and then once the roller comes across on this side, and the laser scans the next layer, then that layer moves down actually 4/1000ths of an inch, which is like the thickness of a human hair, to make room for the next layer. And then this side now moves up slightly with more powder, and then the roller rolls that powder across to that side, and then you scan again, and you keep doing that till the whole part is complete. And that's sort of what it looks like. And oh, there is sound on this one. Can you turn that up by any chance, or can you hear it?
Layer of material to be prepared. This process continues, and in a matter of hours, the entire part has been built.
It'll do it over again. Well, it should. Well, so I was wrong. Maybe we can go back.
A CAD design is transferred to the sinter station. A roller then deposits a precise amount of powder over the build area. The laser sinters or almost melts the powder to form a single layer of the prototype. The build area piston lowers, and the roller deposits another layer of material to be sintered. This process continues, and in a matter of hours, the entire part has been built.
So that gives you a little bit of an idea. Now, to get a little bit more complicated, what's happening here is that we're actually capable of this additive process to use different powders and have them mix at the same time. So you imagine you have metal powders of 3 different types of titanium alloys, and they're being deposited by little tubes automatically at certain amounts into the weld pool that with the laser that's melting and placing melting like along all the powder. Wherever the laser hits, the powder is melted and solidified, and so it makes a complete layer. And then, you know, just like what you saw in the previous example, it makes the parts that way, layer by layer, but it's with different materials. And so you can have, this is the first known computer-controlled gradient fabrication. And you could imagine, like, say, an engine block that's 100% stainless steel on the inside, and then transitions gradually to 100% copper on the outside to dissipate the heat really fast. And you don't have the problem with the CTE, the coefficient of thermal expansion, between the 2 materials. So if you have 2 different types of materials that shrink and expand at different rates, they start to separate after a while. So here you don't have that problem, because you can make things with different types of metals or in plastics at the same time. And before I get too far, I should pass these things around as well, see if you can pass those. There's just different examples of things you can make, and I want you to be aware that if you look at this rook, there's a helix going up the inside of the rook. Then you'll see a staircase going up on the inside. And that's, I did that so to show that, I grew that on our machine, where it's a $500,000 machine. So it's kind of cool, you know. But it shows that you can't do this in any other process. Same with that brain gear, as I call it, that's going around. So take a look at that. And so now the exciting thing is that as we're able to do different materials, the same company, actually, Optomec, that's been doing this, they've also got another section where they're actually growing layer by layer the electronic transistors and components and that sort of thing at as an additive technique.